Hey my warriors, welcome aboard to Enlite, the dedicated English medium channel for NEET as well as JEE. And you are watching the marathon mock test series where I'm conducting special lectures for all the important topics so that you do a quick revision and a grasp of all the important things in the particular unit. And today's unit is all about fluids. So I'm going to do top 25 plus questions on fluid statics, that is buoyancy, Archimedes and all of that. Then fluid dynamics, which includes Bernoulli's as well as continuity. Then viscosity, which has Newton's law, Stokes law, terminal speed and all of that. And then surface tension, which is bubbles, drops, pressure difference and all of this. All of this in today's session with me, Shreyas, your physics master teacher at Vedantu. I am teaching for almost more than 12 years now. And I'm so glad and proud that many of my kids are right now in the top-notch colleges of the country, and you too will be very soon in the weeks to come ahead. So make sure you are attending all the classes over here and follow the guidelines that I have been giving you, because whatever I say comes out of experience of producing all the top 2-digit ranks in all the competitive exams, be it KVPY, JEE or NEET. If you want to know more about me, you can definitely check out my Instagram profile, Shreyas, that's Captain Shreyas. Alright, so let's begin with the class. Hi Badri, hi Darshini, Srimati, Jaya, Krish. Welcome, Mystic Hero. Good evening, Jia. Nice to see all of you. I hope you guys are doing great. And in the final leg of preparation, it's all about questions and filling up the gaps. So next 1 week, make sure you quickly go through all the units which you want to get a stronghold of. Trust me, it's very easy and also important to score 150 plus in NEET Physics. The paper is going to be simple. It's not going to be very difficult except for maybe 10% of the questions here and there. But the remaining 90% questions will be, doable. You can do it within the time period. So don't focus on the remaining hard 10%. Focus on the 90%. That way you will easily score above 150. To get 180, yes, you need to solve everything. Khushi, good evening, bacha. What is the best book to practice JEE questions for class 11th chemistry, physics and maths? I think I had made a video, Lakshant RXA, on 11th standard strategy and what books to be followed. Just check out that video, it's there. Just search for 2024 Shreyas Sir on YouTube, you will get it. If you are not able to find, leave a comment after the session ends. I will ping you with the link of that video. Good evening, Sahana ji. Is this session useful for JEE second attempt? Definitely, Jia Kirti. If you want to master fluids, then these are the top 25 questions for both JEE as well as NEET. Is the fluid concept same in mock, in JEE and NEET, I guess? Supreme, yes. Concepts are same, obviously. Okay, so let's start and make sure you are a part of the Telegram channel, because that's where you are going to get the PDF with handwritten notes, important notifications and updates. Link again is there in the description box below. I'll just show that to you. It's very important that you have a look at all these things. So while you are watching this video right now, you will see if you click on more over here, this is where you are going to find everything. The Telegram channel link, just click on it. If you're on the app, you can just click on this and you will enter the Telegram group. Also remember, it's very important to check out these two links. There is a NEET batch which has just started. This is a live batch. Make sure you click on this. Let's say you want to take it up in English. And this is a live batch, 8,100 rupees, 3-week course, 60 classes with assignments and test series with the top-notch teachers teaching you the NEET syllabus for physics, biology and chem together. Very affordable. Make sure you use the coupon code SHHPRO. For any course at Vedantu, you get the maximum discount that is possible. So let's begin with the class, my warriors. Here comes the first question on your screen. Let's see what it is. Is this lesson used for JEE? Definitely, Supreme Raja. Oh my God, you will be giving the term exam after 2 years. All the best, Kushi. Feels very weird. I know you are that batch from 10th who did not give the exam. Okay, so what are the do and die chapters for NEET? So it's basically modern physics. Then you have to do electromagnetism and mechanics. These are like must do. Okay, electromagnetism, modern physics, that includes semiconductors and all of that. And then you have your mechanics. These are 3 must do things. Hi Rathod, what is the question? A solid sphere made of some material surrounded by liquid is in a container. A piston floats on the surface. When you place the mass on the piston, the liquid compresses. What's the fractional change in the radius? So, oops, let me just go back. Just 1 second. Let me get my pen out here. Fractional change in the radius. That means delta R by R is what is asked. Let's try to visualize the scenario. There is a cylinder, like you can see, and that cylinder has some kind of a piston which can slide up and down. Okay, this has some area A, and in that you have put a sphere of certain radius R. It is surrounded by some fluid like this. Okay, it is surrounded by some fluid over here. Now you put a mass on top of this, which will definitely apply mg force on it. It will definitely apply mg force on it. That creates the extra pressure. When pressure is there, what will happen? Volume changes. And when volume changes, radius changes. So let's use the definition of bulk modulus. Bulk modulus is the change in the pressure upon the volume strain, which is change in volume upon original volume. There is a fractional change in the volume. Bring it over here. So delta V by V will be change in the pressure by bulk modulus. Now the pressure has changed because of the weight. So the weight by the area is going to be the increase in the pressure. So this pressure change has come because of the additional weight that you have put. So that will be mg divided by area divided by bulk modulus. But I will get delta V by V. But the question says find delta R by R. How do I do that? I think you should think about units, dimensions and errors. There is a clear-cut relationship between the volume and radius. Volume is 4 by 3 pi r cube. If this is the volume, how is fractional change in volume related to the fractional change in radius? Remember errors. If you want to find relative error in V, ignore the constant, take the power of radius, which is 3, and multiply it by the fractional change in the radius. Isn't this? This was there in errors and dimensions. So just put it over here. So this will be 3 times delta R by R. So delta R by R will be, just take that 3 below over here. So it will be mg divided by area is also there, bulk modulus is also there, and 3 is also there. That's it. That's the answer. It's option B, of course. You can see that option B is the correct one. So we have the concept of bulk modulus. We also have the concept of errors. That's one of the first few chapters of 11th, and the concept of pressure change caused by the weight which is kept on it. If you draw the diagram, things become very clear. Else you might just worry about the formulas and not know how to solve. Drawing diagrams is very important. Very good, Thana, Vijay Kumar, Srimati, Excellente, Darshini, awesomeness. Guys, keep posting the answers and make sure you smash the like button and also hit the subscribe button so that you do not miss my next class. Hello, Georgie Deepika, nice to see you back again. An incompressible non-viscous fluid flows through a pipe, radius 2r at point A, radius r at point B, and in the flow direction. If the speed at A is v, what is the speed at B? Again, I think we should start with the diagram first. There is a ideal fluid, incompressible, non-viscous, steady flow. It's like the best kind of thing which can happen. This is the standard assumption which we also do in fluid mechanics. So the pipe has a radius of 2r at point A. So the pipe has a radius of 2r at this point A and radius r at point B. So the radius is r at a point B. So the pipe is basically something, let's say like this. As per the question, the speed at point A, is v. The question is what will be the speed at point B? The logic used over here, Alpha Gaming, I have already done all the major chapters, very high weightage chapters before this. Now these are those chapters which have little bit less weightage, but questions will come from this. And if a question comes, you should be able to solve the question. So that's why I'm doing question solving for the other chapters. Like I did for mechanics recently. I am now doing it for fluids. Maybe I will do it for one more unit as such. Okay, so I'll do one more unit after this, and after that we'll be back to the mock test as usual. Yep, use continuity equation. So using continuity equation, what will you get? The area here will be pi into 2r square into velocity will be equal to pi into r square into velocity at point V. Pi goes, so it will become 4r square into V is equal to r square into VB. So VB will be 4 times of V. That is the answer. Yes, I hope this is clear. That's option D. So Chaitanya, like I mentioned, the question papers are very easy. So that's the reason why I'll be focusing on VIT EEE and also the BitSat, number 1. Number 2, like I told you, paper was easy. Number 3, I'll be posting the PDF of the answer key, on this channel itself, on the Telegram group. So if you're a part of Telegram group, you would have seen till yesterday whatever questions have come, I've already put it up. Number 4, like I told you, I think yesterday also, that I'll be doing all the important questions. Because easy questions, again, no point. We have already done that in the mock test. It's all repetitive. All the important, difficult, tricky questions, I'll be doing it as a separate session from all the shifts. 1 or 2 sessions, depending on the number of questions. So that's the way I'm going to go about it. Okay, bacha? I hope that makes sense. It will save you a lot of time, or else I'm discussing the same thing again and again. BitSat is there. Oh my God, the CBSE 12th results are out, is it? Oh my God, good. Okay, let's move on to the next question now. Okay, maybe you can check and tell me. Liquid rises to a height of 2 cm in a tube. The angle of contact between the solid and the liquid is 0. The tube is depressed more now, so that the top of the capillary is only 1 cm above the liquid. The new angle of contact is going to be, let's try this out. See, if you have a tube which is immersed in a liquid, okay, and let's say the liquid rises up till certain height. Okay, this is the height till which it rises. It makes certain angle. This height is given by 2 times surface tension into cos theta by rho g r. This is what it is. But if you are allowing it only to rise till certain height, then what will change is the angle of contact. Because surface tension for a liquid is fixed, density of a liquid is fixed, acceleration due to gravity of earth is also fixed, the radius of the tube is also fixed. So if you try to tamper with the height, the value of cos theta will also change. They both are directly related to each other. So hence you can see earlier the height was this much, now the height is this much, earlier the angle was this much. What is the new angle? So hence h2 by h1 will be cos theta 2 by cos theta 1. This is what you do when you change the height. Oh, I don't know when is the expected dates. I don't know, bacha. It should come out very soon. That's all I can say. So final height is 1. Initial height was 2. Final angle, I do not know. Initial angle, 0. So it will be cos 0. So cos 0 is nothing but 1. So it will be cos theta 2 itself. This is 1 by 2. Whose cos is half? The angle of 60 degree. So cos 60 is half. That's it. That's the answer. Done. Awesome. Let's see. Option C is correct though. Cool, my warriors. Shall we move ahead to the next one? Coming up on your screen. Here it is. There is a liquid which reaches equilibrium, and as shown in a capillary tube of some internal radius, surface tension is T, angle of contact, density, pressure difference is asked between points P and Q. Interesting. The question says, find the pressure difference between this point and this point. This is just below over here, and this is basically at the level as outside, which is basically P naught. So that's the question. Okay, let's try to find this out. Guys, I am pretty sure you can see that both the points are inside the liquid, and these 2 points are separated by some height h. So the pressure difference between points P and Q should be basically the hydrostatic pressure due to the fluid. And what is the hydrostatic pressure due to the fluid? It is nothing but rho g into h. Density is given, g is, let's say, assumed. Height formula everybody knows for a capillary tube. It is 2s cos theta by rho g. rho g cancels, rho g r. So rho g cancels. So 2s cos theta by r. Is that answer there somewhere? Yup, I think option A. Here I have assumed surface tension to be S. You can put it as T also. Some books use S, some books use T. It's up to you. So 2T cos theta by R, that's option A, of course. So the concept used here was, although both the points are inside that capillary tube, you can use the concept that as you go inside a liquid, the pressure varies because of the weight of the fluid above it. And the pressure difference is always rho gh standard. H value, I use it from the surface tension concept. That's all. I hope this is clear. Moving on. Hello RRR. Okay, welcome bacha. Just refresh your screen, probably it should work. My voice should be there, bacha. Okay, moving on. Next question. 1000 drops of water, same size, joined together to form one drop. The energy which is created is used to raise the temperature. What is the temperature change? Interesting question. So let's try to understand what is exactly happening. We have many drops, each of radius r. So there are 1000 such drops. Okay, they merge together and they form one big drop of radius r. This is one drop. In this process, what will happen? The volume will remain conserved, correct? So I can say that the volume is conserved. Okay, volume is conserved. So the initial volume which was there, which is 1000 drops, which each has 4 by 3 pi r cube, will be equal to one drop's volume, which is 4 by 3 pi capital R cube. 1000 is 10 to the power 3. 4 by 3 pi cancels. This is R cube. This is capital R cube. So R is 10 times of small r. This is what the new radius is of the big drop. Now, this is standard model. So many times you will see in JEE, in NEET, in BITSAT, CUET, so many exams, this kind of questions have got repeated with different values. Now what happens is, remember, the area has changed. That's why the energy changes. That's why that energy gets used in heating up the drop. So the formula used over here is USA, United States of America. So change in the energy is S into delta A. So the area change causes the energy change. And this energy change goes into MC delta T, which is the temperature difference which is created across the drop from before. Now heat capacity is given, not specific heat capacity. If specific heat was given, then the heat will be MC delta T. If it is just heat capacity, it is just C delta T. So this will be nothing but C into delta theta. Theta is your temperature difference. That's it. So this is your heat which is being involved. S into delta, surface tension is itself T. Change in the area. So bigger area minus the smaller area. Bigger area is this one. Each drop has an area of 4 pi small r square. There are 1000 such drops minus this area is just 4 pi r square. But this r is itself 10 r. So squaring it, it will become 100 r square. That's it. Now just have to find basically delta theta. So delta theta will be T divided by C. C came down. Rest of the things, let's see what and all is common. 4 pi is common. So I'll just take out 4 pi. So 4 pi from here, 4 pi from here. R square and R square is also common. So R square also taken out. So what is remaining inside is 1000 minus 100, which is 900. So 900 into 4 is 3600. So 3600 pi and T and R square, the whole thing divided by C. That is the answer. Is that there somewhere? I doubt if it is there. No. 3600 is not there. 4 into 900 is not there. A lot of people just do 1000 minus 100, which is 900, and they immediately get tempted by these numbers, 900. They immediately mark, but forget that there is 4 pi r square also outside. So do not forget that value. So the answer is none of these. Option D. Very good, Srimati. Yep. All right. All right. Okay. Very good. Let's move on to the next one. Which graph best represents surface tensions variation for small changes of temperature for water or basically some ideal fluid. It's a standard fact-based question. It's a fact-based question. This is something which you should know theory-wise. What happens is if temperature increases, the energy increases, the bond will basically become weak, and because of which the surface tension force also becomes very weak. So definitely it can't be option A nor C. Here when temperature increases, surface tension is constant. No. Here it is increasing. No. Now whether it is straight line or a curved line, well, for small temperature changes it will be a straight line. This is a curved line. This is for maybe large temperature changes, or it will be non-linear, but for small changes it is a straight line. It is not inversely proportional. It decreases but does not mean it is inversely proportional. It is a straight line because of this small temperature. Very important. Okay, I hope this is clear. So a lot of people end up marking D, but actual answer is option B. Moving on to the next question. Oh my god, Ankit, I'm so happy for you, bacha. Very good, Ankit. So proud of you. I hope you don't have to give the second attempt and you already will start preparing for JEE Advance. Okay, let's move on to the next one. There is a capillary tube experiment, vertically 30 centimeters long, dipped in liquid. Water rises only till 10. If this is now in a free falling elevator, then what will happen? In a free falling elevator, first of all, tell me one thing. Will the apparent or the effective gravity be G plus A or G minus A? Thank you so much, B2B Prime. আমি ভালোবাসি শ্যাম বাঙ্গালু, আমি ভালোবাসি। তুমি কেমন আছো স্যার? Oh, that means I think, how are you? Yep. So guys, tell me, what is it? G plus A? No, it is not G plus A, it is G minus A. Here A is itself G because it's a free fall, so answer is 0. So effective gravity is 0. And why is it minus? Because when you fall down, pseudo force is up, weight is down, weight cancels the pseudo force, so G minus A. Hence it is G minus A, not plus. If you go up, pseudo force is down, pseudo force and weight both are together, hence they will add up. Now remember the formula for surface tension's height rise in capillary. It was 2 times S cos theta by rho G R. Now if G becomes very small, then height becomes very large. But obviously there is a capillary tube of certain defined length whose length is itself given as how much? 30 centimeter. Obviously you can't rise above 30. What is there above 30? Nothing. So you can't go above 30 centimeters no matter what you do. So even when the water comes, it will only fill up till here. It can't go above that. So the maximum height that is possible is as large as possible. So it will be 30, not 10. Hence the correct answer is option C. So a lot of students make a mistake and end up writing 0 or 10. They think, no, it is not going to go up, it's going to stay there. No, it's going to go up and fill up the tube completely. That's what will happen. Okay, fine, sure, Khorse Akmi. I hope you are by the same name on Instagram, or else I might miss, or maybe, I don't know, check out or some other message. Okay, because the inbox is full usually, but still I will try to check it out, definitely. Khorsa Akmi, definitely. Okay, cool. When can we expect results? By around 5th July to 10th July, somewhere around that. Definitely Khorsa, then I'll check it out. Okay. G minus A, very good. Srimati, very good. George Deepika, awesomeness. Let's move on to the next question. What do we have? A homogeneous solid cylinder, as shown, is in 2 liquids. The question is, what is the density of the solid? These densities are given. It's a very standard question. Sham, like I said, bacha, we will not be doing paper discussion. Instead, I'll be giving you the PDF of all the answers. Questions are simple. Number 3, BitSat is near. Number 4, conducting a special session only on the important, tricky, conceptual questions of all the shifts. that will save you time and that will help you for the next few exams preparation. Okay, that's the reason why I'm doing it. Okay, now whenever you see a solid immersed in two liquids, what you should do is first think about the free body diagram. Obviously the solid will have its own weight, so the weight will act downwards. This is the weight of the solid, and it's partially immersed in this liquid and partially immersed in the other liquid. So this part is immersed in this liquid, so there will be a buoyant force like this, FB1, and this part is immersed in this liquid, so there will be another buoyant force, FB2. So what will happen is the weight of the liquid, the weight of the solid, which is downwards, will be balanced by the buoyant force 1, which is acting upwards, plus the buoyant force 2, which is again acting upwards. That's it. Now what is weight? Weight is nothing but mass into gravity. What is mass? Density into volume. Correct? Density into volume. So what is the density? Density of the solid is d. What is the volume of the solid? Let's say this has some area. Let's say small a, assume. So density into area into the height of the cylinder, which I believe is L. So that is density into volume and into G. That is the weight of the solid. That's the LHS. On the RHS side, let's see. Buoyant force in general. What is the formula? Volume submerged into density of the liquid into G. That's the usual formula. What is the volume submerged for liquid 1? It's the area into the height. What is that area? It is A. What is the height? It is 3L by 4. Okay, into density of the liquid. This liquid has a density of D. So put small d here, into G. Plus the other liquid, the volume submerged is slightly different. Notice that this height will be L minus 3L by 4, which is L by 4. So this volume will be again area into height, which is L by 4, into density of liquid, you can see is 2D into G. So it will be 2D into G. See, many things are going to get cancelled. Like L will get cancelled, right? L will get cancelled. Then you can see G will also get cancelled here and here. Okay, area also gets cancelled here. So I'm just left with this capital D is equal to 3D by 4 plus here you have 2D by 4, which is nothing but 5D by 4. That's the answer. Yes, it is. That's it. So now you know the standard kind of question which often comes in many competitive exams. In fact, all the questions that I'm doing are very high frequency, high probability model questions of fluids. Okay, cool. Let's move on to the next question. This everybody should be able to do. Which one of the following cases liquid will flow in the most streamlined manner? You can see it's a question on viscosity. Try to think, is there any relationship between viscous liquid, maybe the radius, and also maybe viscosity and the streamline nature? Is there some criteria, is there some formula for this? I feel there is. Try to recollect. Which formula relates streamline flow and viscosity and the radius and density and all of that? There is one number. There is a number. Which one is it? It's called as the Reynolds number, and that is rho into velocity into the diameter by the coefficient of viscosity. Yes, the Reynolds number, very good. And according to Reynolds number, when this Reynolds number is low, okay, if you want more streamline, then this Reynolds number should be basically very low. As low the value, more streamlined it is. That means viscosity should be high, diameter should be high, density should be high. Now, which of the following options matches everything? Velocity also should be high. Okay, velocity is high, density is high, diameter is high. I think the low density, no. High density, I think that is option, yes, liquid of high viscosity. Low density, oh sorry, I wanted, guys, I made a mistake over here, sorry. I made a mistake over here. Say I wanted low Reynolds number. Low Reynolds number means high denominator, and you want to have low density, low diameter, low velocity. So this numerator should be small and viscosity should be high. As simple as that. So that is happening in option B. Yep, high viscosity correct, low density correct, and small radius or diameter also correct. Option B. Very good, Georgie, Deepika. Moving on to the next one. Let's see what's the next one. If A denotes the area of the free surface of a liquid and at depth h there is a small orifice, what's the speed of the liquid through the orifice? So this is my container and this is orifice. Okay, this is area A and this is small area A. Interesting. The liquid is filled till here and the liquid will flow out like this, and it will come out with certain speed, let's say V. It goes down here with speed U. Question is find the speed V. I think we have to use Bernoulli's principle, and to use Bernoulli's principle you always need a standard height, reference height. So let's make this reference height as 0. Based on this reference, I'm going to measure all the heights of the cross section. There is one cross section here and there is another cross section here. Let's apply Bernoulli's principle. So by using Bernoulli's principle, what do I get? Pressure over here, since it is free surface, it's open to the atmosphere. Then the next term is rho gh. Yes, this is at a height of h, so plus rho gh plus half rho speed square. So it will be half rho u square is equal to, at this point again it's open to the atmosphere, so pressure is nothing but P naught. Then height is 0, that cross section, so 0 plus half rho, at that point the speed is V. That's it. Many things will cancel. P naught will get cancelled. Check this out. So P naught will get cancelled with this P naught. This density will also cancel with this density and this density. So I'm just left with GH plus U square by 2 is equal to V square by 2. Therefore, GH into 2 is equal to V square minus U square. So therefore, 2GH will be, I don't want U, I want to get rid of it. So there is one way I can do that, and that is continuity equation. So if I use continuity equation, what will I get? This area into U will be this area into V. Therefore, U will be equal to AV by capital A. Substitute that over here. I don't want U, so it will be nothing but A square V square by capital A square. That is V square minus this. V square is common, so V square is common. So I'll be left with A square minus A square by capital A square. So I do not want this, I want V square. So V square will be 2GH. 2GH is as it is. A square gets multiplied and divided by A square minus small a square. So velocity will be root of this. Velocity will be root of this. So I think it is option B, definitely. Awesome. Yep, it is option B. J. Kevin, no bacha. VIT English and Math session will come tomorrow, Arjun. No, I think day after tomorrow. I'm doing English and Math session for VIT as well as BitSat day after tomorrow. Moving on to the next question. So two concepts used over here, Bernoulli and continuity. Diagram was not given. You have to predict the diagram by the given information. Moving on. Equal volumes. Don't worry, J. Kevin, the teachers are very good. I can't be there in every batch, no? So don't worry, the teachers are extremely good. If you find any difficulty, let me know. But I'm pretty sure you will not find. Okay? Equal volumes of two liquids as shown. Two holes are punched. Lighter liquid is on the top. V1 and V2 are the speeds. What is V1 by V2? Okay, let's try to do this. First, let's talk about V1. To find V1, the logic that I will use is, in this big container, this hole which is over here, by the way, the height of that hole is h by 2 from the top. This is at a depth of h by 2. I don't care what is there below. I just only care about, this liquid which is there on the top, because only that liquid is going to come out. What is there below does not even matter. Okay, so the density of the liquid is basically rho, and it is uniform. So to find this velocity, I don't care what is there below that hole. Okay, it could be anything, it could be solid, liquid, doesn't matter, because only these liquid lines, streamlines, will come over here. So this V1 will be nothing but root of 2g h by 2, which is nothing but root of gh. This is your velocity 1. Correct? Now, the question is not to find V1, the question is find ratio. How do I find V2? Because only then I can find ratio. Redraw the situation. For this niche wala, the bottom hole. So what I will do, again I will draw the same thing over here. But this hole, this time, is at a depth of 3h by 2. So this depth is 3h by 2. Okay. Now the liquid which is coming out with speed v2. And the liquid which comes out with speed v2 is the lower liquid which has a density of 2 rho. Keep this in mind. This liquid has a density of 2 rho. The liquid on the top has a density of rho. Now I can't say v2 is root of 2g this height. This is not correct because the liquids are different. When liquids are different, what you do is convert it into one single liquid, the one liquid which is coming out. Which is the liquid which is coming out? The bottom one, 2 rho. The problem is this rho liquid. So convert it into a single liquid. I'll tell you how. First of all, realize that this height is h, correct? And this height, as per the given question, is also h. What I want to do is this. Keep that hole as it is. Okay, keep that hole as it is. I want to ensure that the upper liquid also is of the same density as the lower liquid. This is having density rho, 2 rho, sorry. I don't want that upper liquid because 2 liquids creates a problem. How do I do that? Without affecting anything else. Think pressure by a liquid is rho gh. If I want to replace this liquid with a liquid of density 2 rho, that means I'm doubling the density. But I don't want the pressure to change. I want this to remain the same. If I want the same effect of the liquid on the top, by changing the density, naturally the height should be adjusted. What will be the height? Think about it. What will be the height? The height will become half, not 2 times. It will become half, not 2 times. Only then the pressure will be constant. Makes sense? So let's put that. So instead of this liquid, what I will do, I will put a liquid like this of density 2 rho, but this time the height is h by 2. That's it. This is h by 2. Now you just need to think how much below is this hole? So then you can find out what is this velocity. So for that, the logic that I will use is this level of the liquid earlier was here. It has come down by h by 2. So it has dropped. It has fallen by how much? H by 2, so that you can compensate it. Earlier this was 3h by 2. Now you have reduced it by h by 2. So this height will be this minus, so 3h by 2 minus h by 2, which comes out to be how much? 3h by 2 minus h by 2, 2h by 2, which is h. So this is the height difference between these two levels. Hence, V2 becomes root of 2g into just h, Hence, V1 by V2 will be root of GH by root of 2GH, which is 1 by root 2. Done, done, done. I wish Khushia was there in everywhere and my clones were there. Right now I'm in the Hindi NEET channel. Okay, so there you can find me for all the discussions. But I'm pretty sure I go slowly only in English also. So I hope it will not be a problem here. So I would request you to, follow this channel and both other channels, Hindi channel also. So you can learn, in fact, from everywhere. That will be better. Biotechnology, medical, both are good, but biotechnology, medical is acha. Okay, I need to do research on this biomedical versus bioinformatics. I don't know, bacha. I need to check on that. Decrease in the height will mean change in volume, Lavanya, but I'm not interested in the volume. See, what is this liquid creating? It is creating pressure. So if I don't want this liquid, if this liquid still should come with the same speed, the upper liquid should create the same pressure. So I want same pressure. I don't care mass, volume, whatever is different, I don't care. Pressure, the effect should be same. So I replaced it with 2 rho. So height should become half so that the effect does not change. Yes, JEE second session strategy is coming up tomorrow. I'm going to give it tomorrow. Lavanya. Oh, sorry, who is it? Sri Hari Manjunath. Tomorrow. Can we watch the BitSat lectures of years for logical reasoning? Yes, Shreyas Sir. Day after tomorrow, I'm conducting logical and English session for VIT EEE plus BitSat. Both together. Okay. Thank you so much, Khushi. I'm so glad. So don't worry, I'll keep on teaching you. Obviously, this is a JEE channel plus NEET channel. So I'll be teaching you for both. The tube of a spray pump has a cross section of 8. One end has 40 holes in it of this fine area. Liquid flows inside with this speed. What is the speed with which the liquid is ejected out? Not rejected, ejected out through the holes. Let's draw the diagram to understand it better. This is the tube, and on the other side there are many such small holes like this. And this tube has a big area of 8 centimeter square, which is 8 into 10 to the power minus 4 meter square. There are 40 holes, each of area 10 to the power minus 6 meter square each, as per the given question. In this question, the liquid which enters inside this tube is with the speed of 1.5 meters per minute, which is 3 by 2 meters. 1 minute is nothing but 60 seconds. So this will become 1 by 40 meters per second. Everything I'm converting it into SI units. 3 goes with 60 20 times, 20 2s are 40. Now the liquid will come out from here with a velocity of V. I think we have to use continuity equation, nothing else. So let's try this out. So using continuity equation, area, which is 8 into 10 to the power minus 4 into speed, which is 1 by 40, is equal to, here the total area will be 40 into 10 to the power minus 6 into the speed, which is V. You have to consider not this area, the total effective area. There are 40 holes. KDA, I have already done all the formulas in one shot. It's there. Just go to the playlist tab. If you are a part of Enlite, you will be seeing the playlist tab. The playlist has formula revision session as well. All the formulas are there. Okay. Yes, J. Kevin, Akrosh will have from basic. So it's a long-term dropper batch. Yep. When I had took a formula session on this channel, I'll just show it to you. Okay, just let me solve this question. I'll show this to you. You can find it. So this will become 8 by 4 into 10 to the power minus 5. This 0 goes on the top, is equal to 4 into 10 to the power minus 5 into V. These two 10 to the power minus 5s cancel. So this will become 2. So this will become half is equal to V. So that means velocity is 0.5 meters per second. 0.5 meters per second. There you go. That's the answer. That's it. Hello Puneet Rajkumar, nice to see you, bacha. Let's show you where it is. So guys, if you're on this channel, right, so I'll just show you where you can get it. Just go to, oops, not this. Okay, go to playlist. This is where you go to playlist. Okay, I'll show you where it is. Go down. You will see last minute revision, 0 to hero, flash series and all of that. Okay, so all these major playlists are there. Just click over here. Just click on next. Okay, you will see formula revision playlist. Click on this. You will see complete physics formula revision with tricks. This is the session. It's almost a 2.5 hour session. There is a 12th, 11th standard session also separate, each of 3 hours, little bit more in detail if you want to. But I feel this formula session is most important. Is that clear, everyone? I hope this is clear. Okay. Definitely. Yes, Gayatri. Always. No problem. I'll be conducting it day after tomorrow. Tomorrow is a strategy session for first to second attempt. You'll buy 100% college. Okay. I'm so happy. J. Kevin. Very good. Very good. I'm pretty sure next year you're going to be one of our awesome, super duper results, J. Kevin. Really proud of you. And it's a very bold decision. And I'm so glad you took that decision right away. And I'm pretty sure right now when you start working, you will eventually, have enough time to prepare yourself for the worst of the worst kind of exam. Very good. Let's move on. Terminal speed of gold sphere is this much. Terminal speed of silver sphere is how much? I feel we should solve this by terminal speed formula, which is 2/9. You have G, you also have R square. Difference of the density of solid and liquid, and viscosity is there. Awesome, Kushi. I'm so glad, bacha. Final stages now. Very good. So now think about what is different, what is same. The radius is same if I'm not wrong. Same size. Radius is same, gravity is same, liquid is same. So G, R square and eta are same, 2 and 9 are constants. So terminal speed is basically going to be dependent on the difference of the densities. This kind of question also came recently. Vt of gold upon the terminal speed of silver will be density of gold minus the density of the liquid upon density of silver minus density of liquid. As simple as that. Everything else will cancel. Gold speed is 0.2. Silver speed, I do not know. Density of gold, 19.5. Density of liquid, 1.5. So 1.5 will also come here. Density of silver is 10.5. 19.5 minus 1.5 is 18. 10.5 minus 1.5 is 9. This goes 2 times. So this is 0.2 by velocity of the silver. So the terminal speed of silver will be 0.2 divided by 2, which is 0.1. 0.1. Yes, it is option D. Excellent. Shaista Sheikh. Very good, Tahana. Awesome. Option D is the correct one. So again, like you can see, it's a standard model of question where many things are constant. You have to find the ratio. You need to understand which one is going to vary. It looks like a lot of information. Sometimes it also looks very bit tricky or calculative, but no. If you first write down the formula and then take the ratio and then don't write unnecessary things, it looks very, very simple. Moving on to the next one. Direct question. Okay. So what books I used is no longer relevant so much right now. I used Halliday-Resnick. I used, at that time we used to have something called as brilliant tutorials, correspondence books, my coaching material, H.C. Verma, all that. But now some of the books are not even relevant so much. And plus I have a feeling that, Halliday-Resnick is a good book, very good book, but you need to give it a lot of time. So 2 years of preparation does not do justice to that book. Unless you are preparing from 9th or 10th grade, then it's fine. So H.C. Verma, coaching material, your Tattva material, class notes, and PYQ book, Arihant, D.C. Pandey, these are self-sufficient along with Irodov. That's more than enough. Bernoulli's theorem, option A. Venturi meter, very good. Viscosity meter, no, it's not Bernoulli. Capillary rise, that's surface tension. Hydraulic press, that's Pascal's law. It's Venturi meter. Remember, the Venturi meter looks like this, right? It is based on Bernoulli's principle. You have a manometer over here, you measure the pressure difference, and you use Bernoulli's equation to find the speed. Yep, it's Venturi meter. Next question. Next question. Okay, Cengage is not a good book for physics. Please don't use Cengage. I have been telling you this many times, guys. Please don't use Cengage. It does not improve your problem solving skills. It will just give you a variety of problems. You'll just feel that you're solving, but you will not see that improvement. Okay? So that's what I feel about that book. Otherwise, it's a good book, but for maybe teachers. Now, a block floats. It oscillates with time period t. The question is, what is the time period proportional to? If you know the formula, it's fine. Or else what you can do is just derive it. It does not take more than 1 or 2 minutes. So this is the block of area of cross section A. Okay, and it is floating. It is floating in some liquid like this. This is at equilibrium. But when you push the block slightly below, okay, you push the block slightly below, it will go down like this. You have disturbed it. So you disturb it. This is some random position by amount of x. You will see some extra amount of liquid will be displaced. This extra fluid will create this extra fluid which has been displaced. This will create the extra buoyant force. This extra buoyant force will act like the restoring force on it. See, you're pushing it down, the restoring force will pull it back. So it will come back. As soon as it goes up, then again the force will act down, it will come back. So it keeps on oscillating because the force is opposite to the displacement. So what you will notice is that the extra buoyant force will be nothing but the volume submerged, the extra volume submerged into density of the liquid into G. That volume is area into X, obviously area of the cylinder into X, into rho into G. Put X at the end, A rho G into X. The reason for doing that is because I know that restoring force is K times of X. So this value over here becomes your K. This is like your spring constant. And we know time period of a spring is 2 pi under root mass by K. So in this case for fluids, the time period will be 2 pi under root mass by the constant will become A, rho and G. Now check it for yourself. Which one is true? I think option A only is true. Time period is inversely proportional to root A. Inversely proportional to density, no. Root of mass inverse, no. Root of density proportional, no. Option A is correct. Yes, it is. Very good, Shaista. Very good, Srimati. So, Dinesh, yes, use 0 to hero or 0 to superhero series. Number 1. If you think you have no idea, yes, you will get certain idea about the chapter. Then you will understand which topics you need help with. So, only for that subtopics, watch my detailed class or the crash course. That will be better. Okay, so you have options like that. Okay, so you can start with 0 to hero. You'll get a general idea. You don't have to watch all the lectures. You'll get problem solving techniques, formula is important, how to apply it, that's what you'll understand. And then go to subtopics. Only do certain subtopics which are very important. Don't do everything. An object which is immersed in fluid, in order that the object becomes invisible. To practice daily, I recommend the Tattva book, which is provided by Vedantu, the assignments which we give. Number 1, number 2, okay, very self-sufficient material. Number 3, use DC Pandey or the previous year material, PYQ of last 40-50 years. So that's more than sufficient to keep you busy. Still, if you want some higher level, then IE Rodo. That's it. More than this, you don't need anything for physics. The IE Rodo is only for JEE Advanced, by the way. Thermodynamics, I think I recently did. Okay, if you want me to, but let me see. Okay, so yep, it is perfect reflector. No, if it reflects, then it will shine. If it's absorbing, then it will look black. If you want it to be invisible, refractive index is 1, then it will look like a bubble. Refractive index is 1 for air. This should be the correct answer, because then it will feel like it is a liquid itself, because there will be no bending and turning of light. So it will feel as if it's the liquid itself. It will feel like 1. I'm so glad, Hemal. Nice to see you after a very long time. Awesome. I hope you don't have to prepare now for attempt 2. Directly JEE Advanced. And even if you want to improve the score, don't worry. We are here. Term 2 preparation is going to continue, including BITSAT and CUET and other exams. Moving on. Next question. If you suck through a straw, the pressure reduces to this much in his lungs. What is the maximum height till which you can pull out the water? So if this is the straw, okay, and this is the liquid level, and here the pressure becomes 750 millimeters of Hg. Atmospheric pressure is 760 millimeters of Hg. You are sucking the water till here, okay, and this is this height H, which I do not know. This height has come because of the pressure difference. So I can immediately say density of water into gravity into the height is the pressure difference which is created, which is 10 millimeters of Hg, which is also 1 centimeter of Hg pressure. This is the 1 centimeter of Hg pressure. 1 centimeter Hg pressure, if you convert it into SI units or whatever, into normal formula, it will be density of mercury into gravity into height of that mercury. Height of that mercury, this is nothing but your 1 centimeter. This is 1 centimeter. Rho GH is 1 centimeter Hg pressure. Now on this side, you have density of water into G, of course, into H. Gg cancels. So H will become density of mercury by density of water into this 1 centimeter. Now this value is a standard value. What is that? Mercury is 13.6 times heavier than water. So that's it. This will be 13.6 into 1 centimeter. That means 13.6 centimeters. That's the answer. Option C. So this is the most trickiest part. This is the most important step of the problem, where you need to realize that 1 centimeter pressure of mercury is density of mercury into G into height of mercury, amount of pressure in your standard units. That's all. And rest is very easy. Pressure difference is because of the liquid rising up. So rho GH is the difference of the pressure. Moving on. What about this? Hello Srini, I hope you are doing great. Hello Mona Priya. What about this question? If you take a lead shot and if it falls through a column of some liquid, viscous liquid, how will the distance change with time? Very good, Shaista Sheikh. Option A, it is, because this is your terminal speed. Terminal speed. First the speed will be 0, then it will slowly increase, and then it will stay constant. Very good. Awesome, Ishan. Awesome. I'm so glad you keep coming and letting us know. And also, it's a good thing that you do it in front of others, because then others will also get motivated. Awesome. Awesome. Thank you, LC Gamers. Moving on. The angle of contact for water glass is 0, ethyl alcohol glass is 0, mercury glass is 140, methyl iodide glass is 30. Glass is put in a trough containing one of these liquids, and it is observed that the meniscus is convex. So this is convex. So the question is, what is the liquid inside? Very straightforward. Come on. What should be the answer? Is it A, B, C, or D? Look at this information. It is convex. If it is convex, this angle theta is basically obtuse. This is an obtuse angle. An obtuse is 140, not anything else, and that is for mercury glass. So basically the liquid has to be nothing but mercury. Yes, Srimati, Very good, Thirshwata. Awesomeness. Moving on to the next one. Okay? So it is just convex, so angle of contact is obtuse, hence it has to be mercury. If it is acute, then it will be concave. Straightforward again. Which of the following does not represent streamline flow? Does not represent streamline flow. Thank you, hydrogen, so much. You can put it up to Shimon sir backspace. D option. All right. So let's see. Yep, it is. Very good. This is intersecting. Intersection is not allowed. Definitely, it's a strict no-no. Electric field lines can't intersect. Magnetic field lines can't intersect. Field lines can't intersect. Streamlines also can't intersect. Else you will have two tangents, which is not correct physically. All the other things are correct. Even this is fine. The fluid is going in a circular path. That's all. That's okay. Next one. Two blocks, iron and aluminium have exactly same weight, completely immersed in water. The question is, which one will have more weight inside water? Now they have exactly same weight. This weight is actual weight. But one is iron, one is aluminium. A is iron, which has higher density. B is aluminium, which has lower density, but their weights are same. Weights are same. It's given. What is asked in the question is this weight, which is apparent weight. Apparent weight. And remember, apparent weight is nothing but actual weight minus the buoyant force. And buoyant force is volume submerged into rho into g. Now observe carefully. This iron ball has a small volume, so the buoyant force will also be small. This is your buoyant force. Here the volume is more, so the buoyant force will also be more. Correct? These two buoyant forces won't be equal. This will be obviously lower. This will be obviously higher. So obviously now, if the buoyant force is higher here, you are subtracting a bigger value in case of aluminium or the block B. So the apparent weight will be less for block B. Hence, block B will have less weight than block A. So A will weigh more than block B. Hence option A is correct. Awesome. Very good. That's the logic behind it. I'll repeat. Apparent weight is true weight minus the buoyant force, because buoyant force will be opposite. Buoyant force is different because the volumes are different. How do I know volumes are different? Because their densities are different, but the mass is same. So from that I understood, oh, block B has more volume, so more buoyant force. So you'll subtract a higher number that reduces the apparent weight. That's it. Moving on to the next one. There is a tank. It has an area at the bottom. Water is poured in the tank by a tube of equal cross section, ejecting out from the top with speed v. The question is, will the height increase, decrease, or will it remain constant? This is a standard value of question. Let's try to understand this by drawing a diagram. So this is how it looks like. There is a tap, or say something like this. From this tap, water is being poured with speed v, area of cross section A. It fills inside over here, and some water comes out with speed v. This area is also A. Now, if this height of the liquid increases, this speed will increase. So water will come out faster. If water comes out faster, then again the liquid will come down. But if the liquid level goes down further, this speed will decrease. This is constant. So because there will be more intake than outflow, the level will again rise. So it will attain some kind of an equilibrium. So this H will be constant when the inflow will be equal to the outflow. You will see then whatever is the height, it will remain same because whatever is coming in is going out. So that will be the stabilized height. So it keeps on rising wrong. No water can be stored in the tank is also wrong. Water level will oscillate. No, it will reach some equilibrium. and then it will stop. It will always find some equilibrium. So inflow is nothing but A into V. Outflow, oh sorry, this is some other velocity V. So outflow will be A into V. A cancels, so V will be equal to outflow velocity, efflux velocity, which is root of 2gh. V square will be 2gh. So h will be V square by 2g. So that is the answer. Option C. So this water will rise till this height and then it will basically remain stable over there. That's the answer. Moving on to the next one. Water goes up in a vertical tube, length 10. Tube is inclined at 45. The length of the water which will arise in the tube will be. This is a concept based on the tilting of capillary tubes. So if you have a normal tube, okay, and let's say the liquid rises till this height, let's say I call it as H. Now, if you tilt the tube at some angle, okay, it could be any angle, let's say theta, what does not change is the height. The height does not change, but the length inside the tube, this length will definitely change. In fact, you can see L's cos theta component is H. L is something I do not know. Cos theta means cos of 45 is equal to height, which is 10. So L will be 10 root 2 centimeters. That's it. Option A is correct, not C. Option A is the correct one. So the point over here is that the height does not change. And why does the height does not change? Because the pressure difference always depends on the height, not on the lateral displacement, horizontal displacement. So here also same pressure difference will be there. So that's the reason why their heights are same. The lengths will be different in the tube depending on the angle. I hope this is fine. Let's move on to the next question. Okay, what do we have over here? There is a water which goes up in a tube such that the upward force by tension is balanced by the weight. If surface tension is given, what is the circumference of the capillary? So let's assume that this is the capillary tube. Okay, this capillary tube goes like this. This is the cross section of it. Surface tension is acting upwards as per the question. So surface tension will act like this throughout the length of the circumference, something like this. This is the force of surface tension, and it's mentioned it is balanced by the weight. Okay, S is given, circumference is asked. This entire length is your circumference, that entire length. We all know that the force of surface tension is nothing but equal to the surface tension value into the length on which the force acts. This value is clearly given to be 75 into 10 to the power minus 4. T is given to be 6 into 10 to the power minus 2. Length here is the circumference. So circumference will be 75 by 6. Here only 10 to the power minus 2 will remain by cancelling. 6 goes 2 times and this will go 25 times. Okay, so this will be nothing but 12.5 into 10 to the power minus 2. That's the answer. See this? Check this out. Yes, it is 12.5 into 10 to the power minus 4. So the concept here was force is SL, or surface tension into length. Length is the circumference. Surface tension is given. Force is given. That's all. You need to solve it by substitution. It looks difficult at the start, but actually it is not. When raindrops fall from a height, we observe that. Interesting. Come on. Hello, Clay Tsunami. Nice to see you after a long time. What is the correct one? Selva Kumar, if you are in 12th giving the exam this year, then you should watch one shot. But if you are just entering 12th from 11th, yes, please take your time. Watch my lectures, watch the recordings. If you are a part of my batch, you can also access my problem solving HC Verma course and so many derivation courses. Everything you can attend if you are in the pro batches. So that way you will be able to, cope up with momentum and collisions. B. No, it is D. Oh, my bad. This option C and D, there is a mistake. This was supposed to be independent. This is independent. It depends, because remember terminal speed has something r square over here. So definitely it depends on the radius, and they fall with the terminal speed. We all know that it starts from 0, slowly increases the speed and then becomes constant. So it obviously falls with the terminal speed and it depends on the radius. That's the concept of terminal speed. Oh, okay. Oh, you are already passed out student. Yes. Why do I feel that? Okay, you're still in 12th standard. Who is going to give the exam this year? Wow. Where are you doing quantum physics now, engineering? In which college, Clay Tsunami? You can probably motivate the juniors. Awesome, bacha. I mean, like crazy. Yeah, I lost track of time thanks to COVID. It all feels like it's just 1 month. PES Bangalore. Very good, bacha. Nice to know, bacha. Very good. Keep it up. Very happening field. A lot of scope in the near future. Keep it up. The power required to move a sphere in viscous fluid with constant velocity, V is P. The speed is doubled. What is the new power? Yes, guys, all the people who want to do quantum, CSE, PES Bangalore, that's where Clay Tsunami is, who can also guide you with whatever you want to ask him. Definitely. He's our he's our alumni now of Enlite channel. That time it was Enthuse, now it is Enlite. Okay. So, power is nothing but force into velocity. So, if you want to push a sphere with a constant speed, that force which you need to apply will be balanced by the drag force, and the drag force is 6 pi eta r into v. That's Stokes' law. If you push anything, there is a drag force. If you want to push it continuously, you need to apply exactly that force, which is the drag force. So this will be 6 pi eta rv into v. So power is proportional to v square. So that means if speed is doubled, the power will be made 4 times, because square, if v is doubled, v square is made 4 times, power will be also made 4 times. That's answer C, of course. Very good. Wow, first year is also over. So fast, time is flying. Nice. Those documentaries are always fun. Good evening, Divyashri. Very good, Srimati. Awesomeness. This was a tricky question. A lot of people write it as double, or maybe, I don't know, half also, but that's not correct. Now let's also take a moment to, appreciate, just like we have Clay Tsunami over here. There are so many other students who have made Vedantu really proud. You might know them, you might not know them. They are your seniors, they could be your batchmates. So in KVPY, Vedantu got really amazing results. Many of these students are from just the KVPY special batch. Some students are from our long-term batches. So it's a mix of both the students, and they have got amazing results. Just look at it. Just it will take 1 or 2 minutes. 44 results by Vedantu alone. So this number might look small, but let me tell you, KVPY itself announces very few results. It's not in thousands. Okay, it's not like 5,000-6,000 results are announced. No, it's very few. Top 10, you have 5 Vedantu students. Top 100, 10 students. Crazy. Look at the ratio. Top 1,000, 30 students. Look at them. SA topper, that's your 11th standard KVPY. That's Aditi Singh. Rahul Kumar, SB branch. That's 12th standard biology. 5th All India rank. Devyanshu Malu, All India rank 5 in Essex. That's for engineering. Crazy, and so many more. Look at their names. Look at their faces. They have made everybody proud. And these students are from almost all the parts of the country. And if you feel that, oh no, sir, I want to increase this number even higher, then come on, guys, let's join the revolution. Make sure you're a part of the batches which are running out right now. Motivate your juniors. Spread the word. You might be passing out this year, but you have to make sure that all the students make the best use of the best teachers. When you know that, you have to guide your juniors, your maybe, colony mates, your friends, your relatives, who knows. So if You know a student who feels that I want to prepare for KVPY, I want to prepare for NEET, I want to prepare for JEE, I want to prepare for boards, I want to prepare for, you know, COET. You have all kinds of courses, and you know the facilities that you get. You don't have to waste time, you don't have to waste energy, traveling costs, prices are hardly 1/4, 1/5 of the offline coaching. Best teachers, you don't have to travel, best material, all kinds of things, don't have to buy many books. So, you know, test series are there, online analysis, assignments. For every course, you have so many special things with doubt solving and all of that. And yes, if you want to make the best advantage of the prices, make sure you give them the coupon code as well, which is SHHPRO. SHHPRO, that's the coupon code which will give them maximum discount. So make sure you also become the brand ambassadors of Vedantu, and you need to spread in the word, because you are the students who are going to, you know, motivate and inspire your juniors. You're going to pass out, most of you. JEE 2024, yes, very soon. Look at my voice. This is my 5th class today, by the way, and my voice is gone now. That's it. Yes, Kushi, I'll be waiting, Bacha. I will definitely wait for each and every one of you to come in the chat box, just like Clay Tsunami did, and tell me, sir, right now I'm doing this in this college, I'm doing this in that college, I'm in this city, I'll hope to see you. So, you know, I would be really, really happy. Partial mock tests available for class 11th. I need to attempt them. Let me see, Bacha. I'll try. Okay. I have sent 3 students in Vedantu. Oh my God, Kushi, very good. Proud of you, Bacha. I mean, really hats off. Thanks to students like you only, students get more awareness of the courses, and they save money, and, you know, they save time and energy. I'm so glad you have produced 3 ranks. Think of it that way. Thank you very much, guys. Have a great time. I know Chennai Institute of Technology, one of my juniors is ex-alumni now of CIT. It's a very good institute for especially maths. Yep. We changed the name from Enthuse to Enlite because there was a separate channel called as Enlite that was for NEET, and we had Enthuse, which was for JEE. So NEET and JEE, we thought we should have the best teachers at the same place, similar things we do. So we combined Enthuse and Enlite, and it became Enlite. That's the logic behind it. Okay, cool. Thank you, Anisha. And do not forget to smash the like and the subscribe button. Take care. See you again tomorrow. Special session for JEE students tomorrow, and BITSAT and VIT session day after tomorrow. Okay, more sessions will follow for, you know, BITSAT physics mock test as well. Hasta la vista. Take care. Bye bye. Good night.